Yeah, thank you very much, everybody, for Carl and Michelle for that introduction, and thank you all for inviting me here to speak today about sustainability in robotics. So yeah, I started looking at, I'm a philosopher. I'm in DCU, Dublin City University, in our School of Theology, Philosophy and Music. And I started, my main philosophical interest would have been around the environment initially, and then moving into technologies. So most recently, I was on a project called InBots, which was about social robotics. And that brought me to talk about sustainability in robotics, because I realized there wasn't a huge amount being discussed about robotics from an environmental perspective, at least in the philosophical literature. So today, that's what I'll talk to you about. I'm going to talk, I suppose, give you some background about the environment. I hope it's not too boring or too sort of old hat. Then I'll talk a little bit about some applied philosophical questions that I think are interesting, particularly for robotics. And then I'll talk more generally about the moral frameworks that I think might be useful for discussions on sustainability and robotics going forward. So just to put the environmental issue in context, the world's scientists calculate that emissions must fall by half by 2030, 7 years, to give us a good chance of limiting global heating to 1.5 degrees centigrade, which they feel we need to do in order to avoid cascade effects and runaway global warming. The UN's World Meteorological Organization has found that the concentration of climate heat and greenhouse gases has hit a record high, 50% higher than it was in 1750 before the Industrial Revolution, which sparked obviously the widespread burning of fossil fuels. We're also facing, alongside global climate change, we're facing crop loss, soil degradation, mass extinctions, pollution of many types, and now pandemics. So leading scientists are telling us that the planet is facing a ghastly future of mass extinction, declining health, and climate disruption upheavals unless urgent action is taken. Put this into a further bit of context. If we think about animal life, over 99% of all animals that have existed are now extinct, it's believed. The last time our atmospheric carbon dioxide amounts were this high was more than 3 million years ago, during the mid-Pliocene warm period, when global surface temperature was 2.5 to 4 degrees Celsius warmer than pre-industrial levels. Seas were at least 9.1 meters or 30 feet higher. The planet was yet 2 to 3 degrees higher in global temperature, and Homo sapiens ourselves had not yet evolved. So I think this is the broad context that we need to consider the issues around robotics and sustainability. We need to really think about our deep history and the planet's history and our place in that. Nonetheless, I think robots can play a role in helping us combat these challenges or overcome these challenges. So robots can be used for a number of environmental goods, and sometimes we can use robots for explicit environmental ends. We might monitor health and ecosystemic changes. Could use drones to sort of track deforestation or desertification. We can potentially control pests or plant crops. We can clean up pollution. We can fill ecological niches. One of these examples would be using robotic pollinators. We can recycle or reuse dangerous or precious components such as e-waste, which require complex and adaptive handling. The uptake of environmentally friendly AI-enabled robotic solutions can help us meet our targets related to cutting greenhouse gas emissions and relating to achieving climate neutrality. We can also combat environmental disasters using robots. We can use robots to battle forest fires, to clean up oil spills, and so on. We can deliver medicines and supplies in the case of a pandemic. But robots, like any technology, will have unintended consequences. So now it's thought that, for instance, data centers, which is of great interest to us in Ireland, make up around 3% of total global energy demand. By the end of this decade in Ireland, incidentally, they're predicted to be using 30% of Ireland's energy. So they account for between 1 and 3% of global greenhouse gas emissions. Internet use is accounting for approximately 3.7% of global emissions. In 2019, we generated 53.6 million metric tons of e-waste, and only 17.4% of this was properly collected and recycled. So recycling activities are not keeping pace with the global growth of e-waste, while the demand for rare earth materials for electronics is increasing. There's also, robots could also create new environmental harms. So the deployment and large-scale use of robots can create novel harms. The direct impact of individual robots needs to be assessed. So we need to think about, say, the status of nanobots. Should they be defined as pollutants? Are they robots? We need to think also around the aim of using robots. So are we going to use robots for more efficient resource extraction, to make environmentally harmful activities easier to do or not? So these questions, I think, need to be asked in general about robotics. We also need to consider the infrastructure underpinning the use of robots. Obviously, as Carl mentioned, this will have an environmental impact. And we need to look at the industrial processes for developing and manufacturing robots, the markets that will and supply chains that we'll need for robotic systems, and the systems supporting the everyday use of robots, and finally, their final disposal. So the widespread use of robots could place more strain on global energy supplies, as I mentioned. This will have detrimental environmental consequences if the energy used is not sustainable. And we need to think, as I said, about the disposal. So I come at all of this from a philosophical perspective, and I hope you'll all find the philosophical perspective interesting. In Ireland, people aren't that familiar with it, so I'll introduce kind of what we do. So moral and ethical philosophy are often considered synonymous with ethics being a branch of philosophy that's a normative discipline. But we want it to be anchored to real and plausible scenarios. Applied ethics research might address narrow issues. We might look at issues of, issues of technology, but we can also talk broadly about moral frameworks. The ethical frameworks that we most commonly talk about are utilitarianism or consequentialism, deontology, which is concerned with rights and principles, and virtue ethics. So we want our laws, regulations, policies, and codes to be built upon such ethical and political theories. We want them to have some sort of justificatory foundation in ethical thinking. These should serve as reasons for adopting one policy or another. So the most common framework, and the one that we're most interested here today, is the Sustainable Development Goals. And time is running out to put robotics at the service of climate-related efforts. At the very least, we can say it's imperative that the sustainability problems of our current practices around robotics be addressed as soon as possible before their use and production becomes scaled up. This stems, I would argue, from a general moral duty to preserve or conserve things of intrinsic value. This is normally considered to be human beings, but environmental philosophers are beginning to look at other parts of the world as having intrinsic value. So new developments now locate intrinsic value, not just in human beings, but in other sentient beings, other animals, life in general, or sometimes even in ecosystems. If we would accept that there is a duty to preserve things of intrinsic value, and we accept that these other entities have intrinsic value, it would follow that there is a general duty to preserve and conserve these things. Even if this is not accepted, of course, there's a practical case based on human interest to preserve the environment on which we all depend. And I would argue that robotics as an industry would have a general duty to, like everyone has a general duty to try and conserve things of intrinsic value, and also have a practical pragmatic reason to try and preserve the environment on which we all depend. So in terms of sustainability and the sustainability or sustainable development goals, sustainability is most commonly understood as a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. But it's not always considered conceptually clear, which is always of interest to philosophers. So there's been a strong and a weak interpretation of sustainability. The strong interpretation says that current generations have obligations to preserve the same amount of natural capital as they possess so that future generations might benefit from it. Natural capital then would be biodiversity, healthy ecosystems, other species, and similar. The weak interpretation of sustainability advocates the preservation of a stock of capital, natural or not. In this case, you might argue that robot pollinators would be as good as pollinators that are the product of millions of years of evolution. So there's debates within philosophy around which version of sustainability we ought to aim for. Furthermore, around the sustainable development goals, there's arguments that they can counteract each other. So you might aim to promote industry, which is one of the SDGs, but this might come at the expense of, say, life and land or climate. So I'm going to talk about how robotics might try and meet its obligations to the SDGs. So we've seen there's been research on AI and the SDGs that says AI may act as an enabler for 134 targets, 79% across all SDGs, generally through a technological improvement. That 59 targets, 35% across all SDGs may experience a negative impact from the development of AI. When it came to the environment group, so climate, life and land, life in the sea, 25 targets or 93% were found for which AI could act as an enabler. This was due to better modeling and predictive power. So we might be able to model droughts, floods, spills, low carbon energy systems, energy efficiency and renewables. This has not been done, as far as I know, in research I've read for robots more specifically than AI. All in all, though, it shows that AI, and I would say robots as well, can play a role in enabling a just transition to a greener world. So transition can be understood as a move from one dominant socio-technological regime to a new one. Socio-technical regimes will include science, technology, industry, laws, culture, philosophies. Many different actors will be involved in any transition. And so what I think is interesting for the robotics industry is to try and work out what role they will have and what responsibilities robotics as an industry might have and individual actors within the robotics industry might have. So we need to think about the role that people can play, that robots and their partners can play in this. So in philosophy, particularly in environmental philosophy, they're moving away from the conception of responsibility as retrospective, which adopts a liability model. And I think this liability model attempts to assign blame based on previous actions. This has been very controversial. There's arguments over who bears responsibility for causing climate change. This can obviously hinder attempts to mitigate it. So you have questions around, does the West, which is maybe less polluting now, have a greater responsibility to mitigate current climate change because historically it's been responsible for the majority of climate change? Or do the major polluters now, which may not have historical liability, have a greater responsibility? So this argument has been ongoing in philosophy, and new models and new discussions have emerged about forward-looking responsibility. And this shifts the attention from liability questions to political and pragmatic reasoning about who and what, who should do what. So this responsibilities in this model arise from connections, participation in social structural processes that would produce structural injustices. Structural injustices are injustices that emerge through systems, and it's very hard to ascribe liability in these systems. So if we think about a forward-looking responsibility, we're going to have different actors. We're going to have individuals, ourselves, we're going to have public and private sectors, public actors, and all of them can bear different responsibilities based on different connections that they have, different roles they play in society. And I think this would be a very interesting discussion to have within the robotics industry. Individual differences in capacities then to act and different social positions will evoke differentiated responsibilities for acting on structural injustices such as climate change. So there's different parameters for ascribing responsibility in this forward-looking sense. We can look at who has the power to do something. We can look at who's in a privileged position, who's able to influence this, who has what interests are at stake. We can look at social capital, and we can look at epistemic ability. And I think academically and in terms of a practical way forward for robotics, I think thinking in these terms about what robotics can do to realize sustainable goals is something that we ought to look at in the next year or two. More broadly, we can look at ethical frameworks. And I think traditionally utilitarian perspectives are common, and they're quite useful in terms of thinking about robotics' impact on the natural environment. Utilitarian perspectives generally focus on a collectivist metric. We want to maximize the greatest good for the greatest number of individuals. That obviously works well with measurable aspects of robotics, measurable aspects of environmental impacts. But it leaves open the question of the good, of what we're aiming for and what we're designing technologies for, what we're developing robots for. And virtue ethics, which is focused on excellences and character, has always traditionally looked at the good. It takes a teleological approach. What is the goal of any activity? What is the goal of any practice? And I think beyond the practical questions of responsibilities to do certain things for the environment that would be useful in robotics, I think it might also be useful to think about the end of robotics, the telos and the goal of robotics. So we might think about technological virtues. These have traditionally been associated with innovation, problem solving, and efficiency. These technological virtues don't necessarily ask us to think about the goal. So virtues of the practice of technological innovation might include collaboration, rigor, and efficacy. But if we think about questions of ends for robotics, we need to discuss this in terms of what are we designing robots for? What do we hope to get from a robotics pervaded society? And what are we hoping to get out of all these novel innovations? So one obvious answer is we want to maximize technological outputs or profits. We want to produce novel devices. But the environmental perspective, I would argue, is needed. And I think we need to both solve specific environmental problems, but also lead, I think we could, or robotics could help lead the transition to a greener, more sustainable world. So I will leave you just with a few questions at the end, my final questions that I hope we can discuss in the group. So what are the ends? What are the goals of robotics? Should we try and have green goals for robotics? Should this be regulated for? Should this be a policy or a code? What would an environmental virtuous robotics industry look like? What would it be aiming to achieve? Where does responsibility lie then for ensuring that robotics is sustainable? Does it lie with consumers? Does it lie with developers? Does it lie with regulators and policymakers? And will codes of ethics be enough? So internal robotics codes of ethics, or are broader regulations needed? So I hope to discuss all these with you. I hope you found that interesting. And thank you very much for listening to me. Please get in touch either now in the chat or at any time on Twitter, or there's my email. Thank you very much.